Dharshana Gopinath, and I'm going to be explaining the Math Kangaroo 2024 Grades 3 and 4 exam. Let's get started. Which square is cut into two different shapes? So, to me, the best way to solve this one is to count how many squares are in each of the parts in each image, in each option, and whichever option doesn't have the same amount of squares in each part is the one that's cut into two different shapes. So we can just go one by one and see how many squares each one has. So this one has 1, 2, 3, 4, 5, 6, 7, 8. And then this part also has 1, 2, 3, 4, 5, 6, 7, 8. Since both parts have 8 squares, A is cut into two of the same shape. Option B, we can easily see that this one is cut in half. And since when a square is cut in half, both the triangles are the same. So B is not the answer. C, we can count it again. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Since both parts have 8 squares, C is not the answer. D, this one's going to be a bit more tricky to count, but if you notice closely here, this line is just cutting through like this middle rectangle here. So if you just count it like 1, 2, 3, 4. Wait, 1, 2, 3, 4. And then this little triangle matches up with this one. And this triangle matches up with this one. So that's 2 more. So, and then 5 and 6, 7, 8. And then it's the same thing on this side. So 1, 2, 3, 4, 5, 6. And these, the same pairings to get 2 more squares. So both of them have 8 squares. So D is not the answer. So it's got to be E, but just to make sure, we're going to count it, just to make sure. So 1, 2, 3, 4, 5, 6, 7, 8, 9. And this side has 1, 2, 3, 4, 5, 6, 7. As you can see, both parts don't have the same number of squares. So the answer is option E for number 1. What is the smallest number of ladders the firefighter must use to reach the fire without jumping between platforms? So the platforms, just to clarify, the platforms are these big yellow boxes. And when they say the firefighter can't jump between the platforms, they mean that if, say, the firefighter was here, then he can't get to over here because there's no ladders between them, and he can't jump over this gap here. So with that in mind, let's try and see if we can go through all of the answer choices. And whichever one we get first, that will be our answer because they asked for the smallest number. So let's try option A, 4. So maybe the firefighter goes this way and goes up 1, 2, 3, 4. But the firefighter's run out of ladders and the fire's still all the way over here. So there's no way the firefighter can get up to the fire with just 4 ladders. Okay. Let's try 5. Maybe the firefighter decides to go this way this time. So it goes 1, 2, 3, 4, 5. We've still run out of ladders and the fire is still 1 platform up. So if we could get this far with 5, I'm pretty sure we'll be able to get up there with 6. Let's try it. So again, the firefighter goes this way. So 1, 2, 3, 4, 5, 6. And the firefighter's up here right next to the fire to fight off the flames. And again, since they're asking for the smallest number, we don't need a test for 7 and 8 because we already know that 6 works. So the answer to number 2 is option C, 6 letters. Samville painted a dark rectangle on his garage's 2 doors. Which of the following shapes could you see on the other side of the open door? So they're asking for what shape will be there for the missing piece of this rectangle. So the only two, if you think about it, only two shapes that you could get is a triangle like this or a trapezoid like this. And since triangle is not an option here, there's no triangle option, we can safely say that the answer is option C, a trapezoid. Soccer players numbered 1 to 11 stand in a circle. Each player kicks the ball to the third player on their left. Player 1 starts. This kicking pattern continues until a player has the ball for the second time. What is the number of the player who kicked the ball last? So when they're asking the number of the player who kicked the ball last, they're really asking who kicks the ball back to player 1 because that's who starts. So we can just continue this pattern until we do find that. So they said third player to their left. So 1 goes to 4, 4 goes to 7, 7 goes to 10, 10 goes to 2, 2 goes to 5, 5 goes to 8, 8 goes to 11, 11 goes to 3, 3 goes to 6, 6 goes to 9, and 9 goes to 1. So since this is now when player 1 got the ball the second time, so that means player 9 is the one who kicks the ball last. So the answer is option C, 9. He wrote 3 consecutive 4-digit numbers in a row. His sister erased some digits. What are the missing digits from left to right? For example, 213, 214, and 215 are 3 consecutive 3-digit numbers. So from the numbers that are still here, we have enough clues to figure out what the 3 consecutive numbers are. And based on what we write here, that will be one of our answer choices. So if there is a 98 here, the number before it's going to be a 97. And the number after 98 is 99. So now that we know what the last number is, we can start by doing some elimination. So option B and option C won't work because the third number is not 99. Now, we know that there's a 4 here, and since these can't be like at the beginning of the 4,000s, we can also say that there's supposed to be a 4 here and also a 4 here. And so this shows us that option A is also not an answer because the middle number, it says it's a 3 when we say it's 4. So option A is also not right. Now, this last one is gonna be a little tricky. But if you notice, both of these numbers have an 8, 9 in the middle. And this number is the only one that's missing that 8, 9. So we can also say that there is supposed to be an 8, 9 here as well. So this means option E won't work either because this says 8, 8. So option E is not the answer. So let's just check. 489, 4, and 99. And the only answer choice that has those is D. So the answer to number 5 is option D. Lucia pays $7 for 3 items. The cost of each item is different and is a whole number. How much does the most expensive item cost? So we can just try a few different options, and whichever one works, we'll take the highest number from that, and that'll be our answer. So let's try 1 plus 2 plus 3. But that only gives us 6. So that's not right. How about we try 2 plus 3 plus 4? Well, now that's 9, and that's too high. So maybe we could try something like 1 plus 2 plus 4. That gives us 7. So this could be one of our options. Or what if we tried 1 plus 3 plus 3? Wait, no, they said that each item is different and is a whole number. And so this is the only option that will give us 7. And the highest number is 4. So our answer is option C, $4. A cat knocks off one block of Felix's construction. What could this construction have looked like before the block was knocked off? So the cat knocked off one block, and the figure that would, the construction that would be the correct answer is before anything was knocked off or removed. And just to clarify, this block right here is the block that was knocked off of the original construction. So there are a few of them that would have to have 2 blocks removed to get to this. This one and this one would have to be removed to get to this. B, this one and this one would have to be removed. C, this one and this one would have to be removed. And D, this one and this one would have to be removed. And some of these answer choices also have a few blocks missing. Like A, there's supposed to be a block here. B, there's also supposed to be a block here. C, there's supposed to be one back here. D, there's supposed to be one right here. So it can't be any of these choices because they're missing a block or they have to be knocked off 2 blocks. And the only answer choice that we haven't done anything to is option E because, well, everything else seems to be adding up except for this one, which must be the one that Felix's cat knocked off. So the answer is option E because the cat knocked off this one to get to this structure. Kangaroo poster on the kitchen wall. The tiles behind on the whole wall form a regular pattern. How many gray tiles are there behind the poster? So we can notice that there are 6 rows of 7 tiles behind the poster, and there's going to be 3 gray tiles behind on the first row behind the poster, and on the second row behind the poster there's going to be 4. And since the pattern is a regular pattern, meaning it repeats, you're going to have the same thing all the way down. And so since there's 6 rows, and on every 2 rows there is 7, that means 7 tiles times 3, because this is 1, 2, 3 of 7. So that means we're going to get 21 gray tiles. So the answer is option B, 21. Alan and Tom toss a coin which has a purple side and a green side. If the child gets the purple side, that child advances 3 steps. If the child gets the green side, that child goes back 1 step or stays at the starting position. Both started at the space marked start, and each tossed the coin 4 times. Carolyn advanced to number 4, and Tom advanced to number 8. How many times in total did they get the green side of the coin? So if Carolyn went to space 4, That means she got the purple side twice and got the green side twice. And that can be represented with 3 plus 3 minus 1 minus 1, because she went forward 3 spaces, forward another 3 spaces, but then had to go back twice because she got the green side twice, which is 4. Now, it doesn't really matter what order she got those in, just that she got the green side twice. For Tom went forward. Tom went forward, got the purple side 3 times, and we can show that by 1, 2, 3. But then since he ended up at 8, he went back 1 by getting the green side. So we can write that as 3 plus 3 plus 3 minus 1 only one time, because he got 8, so which is equal to 8. So he got the green side once. So 2 plus 1 is equal to 3. So in total, both of them got the green side thrice. So the answer is option C, 3 times. Kinds of fruit in a bowl: apple, cherry, grape, strawberry, and banana. Anne likes grapes. Ben likes all of the fruit. Cam likes grapes, strawberries, and bananas. Dan likes bananas and grapes. And Eli likes cherries and strawberries. Everyone gets a fruit they like, but everyone gets a different kind of fruit. What kind of fruit does Ben get? So if Anne only likes grapes, that means she has to get the grapes because everybody gets a fruit they like. So if Anne gets the grapes, and so since everybody else gets a different fruit, we can cross out everyone else who likes grapes so that we don't use it again. And then, so now Dan, if we look at Dan's only left with bananas. So since, again, everyone gets what they want, Dan will get a banana. So we can cross out wherever else there's bananas. And then Cam, now she's only left with strawberries, so she'll get a strawberry. So everywhere else, we can cross out a strawberry. And Eli, the only thing left for him is cherries, so he gets cherries. So we can cross out the cherries for Ben. So Ben is only left with an apple, so Ben will get the apple. So option A is correct, because Ben will get an apple. Ada built a tower of 8 discs, as in the picture. Ada removes the second disc from the bottom of the tower. Then she removes the third disc from the bottom of the new tower. Then she removes the fourth disc from the bottom of the new tower. Then she removes the fifth disc from the bottom of the new tower. Which tower does Ada end up with? So when they say like new tower each time, they mean like if she removes one, that's the new tower. And then again, and then she has another tower which is shorter. Each new tower is shorter than the one before. So let's try and see if we can figure out which one she removed and what the final thing looks like. So the first one she removes is the second disc from the bottom of the tower. So when she removes that, she gets this. So she removes this second disc here, and so she is left with that. And then she removes the third disc from the bottom of the new tower, so then she's left with that. And then when she removes the fourth disc from the bottom of the new tower, she is left with this. And then she has to remove the fifth disc from the bottom of the new tower, which is just like the top disc of the newest tower. And then so she's left with this. And the only option that matches that is option B. So the answer to number 11 is option B. Peter the penguin goes fishing every day and brings back 9 fish for his 2 chicks. Every day, he gives 5 fish to the first chick he sees and 4 fish to the second chick. The chicks eat all the fish they get. Over the last few days, one chick ate 26 fish. How many fish did the other chick eat during those days? So the only way to make 26 with 5s and 4s is if you do 5 plus 5 and then do 4 4s. So that's 26. So how many days is that? It's 1, 2, 3, 4, 5, 6 for 6 days. So one chick ate 5 fish twice and 4 fish 4 times. So that means the other fish ate 5 fish 4 times and 4 fish twice. And so that means the other chick ate 28 fish. So the answer is option D, 28. Cards numbered 1 to 7 are placed in 4 overlapping rings. The sum of the numbers in each ring is 10. Which number is under the question mark? So with the circles that have 2 numbers, we can easily find out what the other number that's left. Since each circle is supposed to add up to 10, we could say that this circle has a 4 in it because 6 plus 4 is 10. And then this circle has a 7 in it because 3 plus 7 is 10. So the answer is obviously not option C or option E. Now, to find out what this number is, what's left? In this circle needs 3 more, 3 to add up to be 7, and this one needs 6 to add up to 7. But the only numbers we have left are 1, 2, and 5. So if we put a 5 here, then that means they just need to add 1 to get 10. And this one, if you add a 2, then you just add 1 to get 10. So that means the number that's supposed to be in here is 1. So the answer is option A. Lucas wants to make a caterpillar that has a head, a tail, and 1, 2, or 3 puzzle pieces in between. How many different caterpillars can Lucas make without flipping the pieces over? So let's take a look at our pieces. If we can see that the apple can't be connected to the head because they have different connectors. Like the head has an oval connector and the apple has a rectangle connector, and those both can't fit. What other pieces can't we do that? We can't connect the grapes and the tail because they both have different connectors. And we can see that for a lot of pieces, like you can't connect the cherries and the grapes together, different connectors. And you can't connect the apple and the cherries together because, again, different connectors. So with that in mind, let's try and see what different caterpillars we can make. So this is our head. That's our head. And what can we connect to it that has a circle connector? Well, we could do the cherries here. So we have the cherries. And then we can also connect to the cherries the tail because those both have the same connector. So that's our tail, head, tail, and the pieces in between. So that's one. Let's try another one. Again, the head has to start at the beginning. And let's try doing the cherries again. But this time, what can we connect other than the tail? Well, we could connect the apple. They both have rectangle connectors here and here. So we can do an apple. And then to the apple, we can connect the tail because they have the same thing. We can't connect anything else together. So we'll put our tail here. So that's another possibility. Another possibility is, instead of using the cherries this time, let's use the grapes, because the head and the grapes also have the same connector. So if we make this our grapes, then we can put the cherries right next to it. And then next to the cherries, we can connect the tail because of the connectors. Right? So we can do it like this. And then I think we can make another one, right? So let's try that, another one. Again, let's try doing a grapes. And then instead of the cherries, we can actually connect the cherries again, can't we? Yeah. So let's connect the cherries. And then instead of the tail, we can connect the apple. So we can connect it with the apple, and then we can finally do the tail. If you ask me, I feel like those are the only things we can do, because we can't connect the tail directly to the head, and we can't connect the apple to the head. So these are the only caterpillars that you would be able to make with these puzzle pieces. So the answer is option B, 4. John writes the numbers 1 to 4 on a sheet of paper. Then he flips the sheet and writes the numbers 5 to 8 as shown. After that, he cuts the sheet into 4 rectangular cards and puts them in a row. What is the sum of the numbers represented by the question marks? So, let's take a look at the sheet of paper. These two edges right here are the same edge. So, when you fold them up against each other like this, the numbers align with each other. So, let's see which numbers align with which. If these both are the same edge, then 6 should align with 2, 8 should align with 3, 7 should align with 1, and 5 should align with 4. So let's write that out. 6 to 2, 8 aligns with 3, 7 aligns with 1, and 5 aligns with 4. So let's take a look at the sheets in a row, the cards in a row. So 5 and 6 are here, which means 7 and 8 are the only ones missing. And these cards are flipped over. So we said that 7 aligns with 1 and 8 aligns with 3. But they asked for the sum of the numbers represented by the question marks. So they're asking for the sum of 1 plus 3 is 4. So the answer is option B, 4. 16. A floor is covered with 2 types of tiles, a rectangle and a square. The size of the rectangles is 23 centimeters by 11 centimeters. The picture shows a part of the floor. How long is one side of the square tiles? So, I have a part of the floor here enlarged, so it's easier for us to solve here. So, they said 23 by 11. So, the long side is 23 and the short side is 11. So, and this part's also 11. So if this short side of this rectangle is 11, then that means these two, the sides of this square tile is what's remaining to make 23. So 23 minus 11 is equal to 12. And this 12 represents both of these combined. So if we want to get the side, just one square's side, we just divide it by 2. 12 divided by 2 is 6. So the length of the side of the square is 6 centimeters. So the answer is option D, 6 centimeters. 17. A student has 3 cards with numbers on them. Their sum is 782. Unfortunately, a worm ate part of each card. What is the sum of the 3 missing digits? So let's just write out the 3 digits with what we have. And then 4, 1, question mark. So, and they're supposed to add up to 782. So right now in the ones column, we have 3 and 4, which adds up to 7. So to get that to 2, we need to add 5 to make it 12. So this first one is 5. And then since it's a 12, we're going to be carrying 1. So 1 plus 1 is 2. And then so these 2 digits would add up to 6. So these two, and we don't need to know exactly what these 2 digits are, just that we need to know that they add up to 6. And since they're asking for the sum of the 3 missing digits, we can just add 5 plus 6 is equal to 11. So the answer is option D. Lucy weighs some blocks. How much do each of the 3 different blocks weigh together? So let's take a look at these scales. If we add these first 3 scales, then we get each of the blocks twice. And so if we divide whatever we get then by 2, then we should get what they all weigh together. So let's add them. 200 plus 100 plus 240 is equal to 540. So if we divide 540 by 2, we should get whatever it is when they are all being weighed together. So all of them together is 270, which is option A. There are 60 students on a trip. When they line up, the colors of their reflective vests follow the pattern: yellow, green, etc. The colors of their backpacks follow a different pattern: red, brown, orange, and so forth. How many students have a yellow reflective vest and also have an orange backpack? So to help us with this problem, I made this table for the first 18 students. And other than the third one here, we can see that the yellow vest and orange backpack repeats every 6 students. So, knowing that, since there's 60 students in total, and the yellow-orange combination comes every 6 times, every 6 students, if you divide that by 6, you get 10. So 10 students will have a yellow vest and an orange backpack. So the answer is option E, 10. In the following calculations, the same digits are hidden under the same figures, and different digits are hidden under different figures. Triangle plus triangle equals square circle. Circle plus triangle equals square square. What is the value of triangle times circle times square? So let's take a look at the first equation. We can see that the triangles are single digits because there's not another shape next to it. So when you add 2 single digit numbers, the only tens place you can get is something that is a 1. So the tens place here is going to be 1. And so all the squares are going to be 1s because they said the same digits are hidden under the same figures. And so this first equation has to be greater than 10 because then this second equation wouldn't work. And it also has to be greater than 11 because then circle would be the same thing as triangle, and that doesn't work because they said different digits are different figures. So that means it has to be at least the first equation has to equal at least 12. So let's try if we did 6 in the triangles, then circle would have to be 5 to make this one true, but 6 plus 6 isn't 15. So we have to try something else. Let's try 7. So 7 plus 7 is equal to 14. The circle is 4. The triangle is 7. 4 plus 7 equals 11. So that means the triangle is 7 and the circle is 4. So if we plug that into here as well, 7 times 4 times 1 is 28. So the answer to this problem is option D, 28. There are exactly 2 frogs in each row and each column. The frogs decide that 2 of them will jump to a neighboring empty cell at the same time. Neighboring cells have a side in common. Afterwards, there will still be exactly 2 frogs in each row and in each column. How many ways can the frogs do this? So there are a few possibilities. Like, this frog could move this way, and this frog could move this way, as shown in this picture. And then this frog could move this way, and this frog could move this way, as shown in this picture. And then another possibility is this frog moves here and this frog moves here, as shown in this drawing. And then our last possibility is this one moves here and this one moves here, as shown in this drawing. So those are the only 4 possibilities that can be done to make sure that 2 frogs are in each row and in each column. So that means the answer to number 21 is option D, 4. 22. The figure below shows a honeycomb with 9 cells. There is honey in some cells. The number in each cell shows how many neighboring cells contain honey. Neighboring cells have a side in common. How many cells contain honey? Let's start by looking at the cell closest to the bee, the one marked with this number 2. It has 2 cells next to it that have honey, which I'm going to mark with a heart. The cell marked next to it, marked with the 4, has 4 neighboring cells that have honey. So all of those also have honey. The cell marked with the 3 already has 3 cells with honey, this 4, and this 2. So this one doesn't have honey. Let's look at this. If we look at this number 3 here, we see that there's already 2 of them with honey, but this one only gets to have 1 cell next to it that has honey. So this one doesn't have honey, and these 3 have it, but this one doesn't, because this number 2 already has 2 cells next to it with honey. So this 3 also doesn't have honey in it. So if we count how many cells have honey, we have 1, 2, 3, 4, 5, 6. So the answer is option C, 6. 3 girls, one after another, take some cookies from the tray below. One of the girls takes all the heart-shaped cookies available on the tray. Another girl takes all of the white cookies on the tray, and another girl takes all of the large cookies available on the tray. However, they do not necessarily take the cookies in this order. So let's take a look at this problem. There are 11 heart-shaped cookies, 7 white cookies, and 7 large cookies. None of the girls took 11 cookies, so the first girl did not take the hearts. If she took the white cookies, there would be 9 hearts left, 4 large hearts and 5 small ones. So whoever went next did not take 3 or 6 cookies. So the first girl took 7 large cookies, the second took 6 small hearts, and the third one took 3 small round cookies. And the only option that has one of those 3 options is letter E, with the 3 small round cookies. There are 2 types of blocks: a white triangle-shaped block and a red block. A small cube can be made using 4 white blocks or using 1 white and 1 red block. The large cube shown below is the picture made of small cubes. What is the smallest number of white blocks needed to make the large cube? The cube in the picture is made up of 8 small cubes, and each cube contains at least 1 white block. We can see that 2 of the small cubes have 4 blocks, like this one, and some of them have only 1 white block, like this one. To get the smallest number of white blocks, the remaining 6 cubes should use only 1 white block each. Therefore, the smallest number of white blocks is 6 plus 4 plus 4, which is equal to 14. So the answer is option D, 14.
Don't forget to subscribe and like. If you have any questions, you can email info@agoramathcircle.org or comment below and we'll reply back. Maybe. And if you want to see practice things or anything about us, you can visit our website. So bye!